Hello, so today we'll do basics of probability. So like what is probability, some things related to probability and everything. So first, even getting into probability, we must understand what this term means, sample space. Okay, so let me just change the font a bit here. So sample space, what do you think sample space is? Sample space is that, let's say we are having an experiment. Experiment is what now? What do I mean by experiment? Experiment is something which you perform, right? So let's say if I'm tossing a coin, or let's say if I'm what do you call it, let's say I'm tossing a coin, let's say I am rolling a dice. That's an experiment. Okay, so that's an experiment that we do, and now from the experiment we get something called the event. So let's say something has happened. Okay, so what is my experiment? Experiment is rolling a dice, while my event is something like getting a 6. So after I do an experiment, I get to know a event. Okay, so getting a 6 is an event. Okay, so my sample space is nothing but the total number of possible cases I can have while doing the experiment. So basically, if I roll a dice, what are my possible chances? 1, 2, 3, 4, 5, 6. So this is my sample space. Okay, this is my sample space. Okay, then event here getting a 6 would be just 6, right? So you can notice something, that event is the subset of sample space. It's very simple to understand this. The sample space is all my cases, event is a specific case of the experiment. Okay, now yeah, so now before we go into probability, some small short discussions about this. I think everybody will know union and intersection. Okay, let me zoom in a bit. Wait. Okay, union and intersection. So union and intersection means what? Let's say if there's a here a thing is there, and here it is like this. Okay, so if there are like two sets, for example, right? So this place, this whole area will be union. So like A or B, and this part is the intersection, the common part, that is the A and B. This is a simple logic. I'll not go in detail. I think everybody knows this, so I'll not go in detail of this. And from this you get De Morgan's law. That is what? A union B whole complement. So whole complement is your what? A complement intersection B complement. Okay, and if you do the ulta, as in like A intersection B complement, that will be equal to A complement union B complement, if you understand. Okay, so this is De Morgan's law. This is the thing you will require a lot during your sums. And if you just do complement, complement is like ulta. So basically, let's say this is my A, right? Let's say this is my A. So A complement will be this area, this whatever area is here. Okay, so this is the simple meaning of that. Now we will not go in depth of what union or intersection is. I think everybody knows. Now we will start with something which is very important, that is probability. Our whole first basis, what is probability? Okay, so what is probability? So let's say I have an event. Okay, let's say event. What is my event? Let's say getting a 5, and my experiment here is rolling a dice. Okay, so now my simple logic of this is that we need to find a relative frequency. What do I mean by that? Okay, so let's say this experiment is there. Let's say we define the sample space as S. Okay, now we have an experiment, and we can do that experiment time and time and time and time and okay, many times. Okay, now we've count how many times, like let's say we'll define this like n, where is where is text, 8. Okay, n of E. What is n of E? That is the number of times the event happens. Okay, as simple as that. So number of, let's say getting 5 is our thing. Okay, by the total number of times we have done the experiment. This is nothing but my probability. This is my probability's definition. So number of the event happening by the total number of events. So that is n of what? The sample space. Logically it's sample space, right? So basically what will happen, what is the probability of getting 5? Only one possible out of the 6. And what is the possible of sample space? 6. So the probability of getting a 5 while you're rolling a dice is 1 by 6. Okay, so now usually you will not get 1 by 6. Like first time it can be 4, right? So it will be 0. The probability of getting 5 is 0, but not possible like that. So it will be 1 by 6. So what you have to do is that you have to repeatedly do this experiment till infinity. then only this answer is correct. Okay, so for one time instance it might be correct, it might not be correct, because it will not be correct, because if you get 5 then the probability is 1, if you don't get 5 it is 0. So you have to do this experiment till infinity till you get this. Okay, now from this we have three things. Okay, so this is called my probability, or let's say P of, here it is 5, so 5, so we'll say it as P of E now. So we have three axioms of probability. Okay, so axioms of probability, what do these probability axioms say? So first axiom says probability of E is always between 0 and 1. So P of E is between 0 and 1 always. Okay, second, it always says the probability of sample space will always be 1. What does it mean? Probability of sample space means what? See, you know everything is in the sample space, right? So let's say your sample space is what, 1 to 6. So in this case, if I had said using this formula only, if ns by s is 1 only, you can see, but what I mean to say is that let's say we have all the cases, right? So let's say 1 2 3 4 5 6, and I tell you what is the probability of getting a number between 1 to 6. It is always probable. That's why PS is equal to 1. Third axiom. So for any sequence, this is a big one, of mutually exclusive events, E1, E2 and so on, where EI, EJ equal to null, where I not equal to J. Okay, probability of union of EI is equal to sum of probability of EI. Okay, so that means what? So basically if you take the union of all the events, so let's say I'm taking a simple example. Okay, probability of 1, let's say we're considering the cases probability of 1, probability of 3, probability of 5. Okay, so now what is the union of this? What is the union of 1 2 3 4 5? That means union of this is nothing but getting an odd number, right? Getting an odd number is the union set now. So the probability of odd is what? My 1 2 1 3 5 by 1 2 3 4 5 6, that is what? 3 by 6 is equal to 1 by 2. That is my LHS. Now let's think about the RHS. We have to do the summation of each of the events. So each of these events is what? 1 by 6 into 3. So that is what? 3 by 6 equal to 1. You can see it works. So there is no proof for these because these are axioms. Axioms don't have proof. Okay, so axioms of probability are these. Okay, let me change the color a bit, I guess. Wait, yeah. Okay, so this is the axioms of probability, and this is how you can think about this. Okay, so these are always true, and you can also, let's do one sum. That would be better, I guess. Okay, the example I gave is actually a sum. By mistake I gave it as an example. So yeah, so this is how we actually can think about probability. So what we did was basically discuss about how probability works, the basic understanding. This is not a definition of probability, by the way. Okay, this is a very crude explanation of how probability works. Then the axioms of probability, the three axioms, you have to actually know all three of them in detail, which I discussed, and this was the sum that we discussed. Okay, this was actually sum which I discussed already. And now we will discuss some results. Now let's discuss some interesting results. Okay, these are some results. Why am I doing this? This is not there, but what I saw in GATE, there were some questions which were based on this results. Okay, so basically if you have basic probability knowledge, you will be able to solve in the exam, but if you know these results, you can do it in like 1-2 lines. Okay, so that is the reason I am doing. Okay, so these are some basic fundamental results you should know, and I'll prove all of them. Okay, because otherwise no reason. So first one is that probability of some A complement is equal to 1 minus probability of A, which is very obvious, right? Why is it obvious? We know P of S is equal to 1. So that means P of A plus A complement is equal to 1. That means what? P of A, so not complement, union is equal to this. So P A plus P A complement equal to 1. So P A complement is equal to 1 minus P A. So this one comes from where? This one comes from this one comes from the second one, this then this comes from the third one. Axiom. We will only be using axioms, nothing else. We'll use axioms to prove everything. Okay. So like you understand, this one comes from here and this one comes from here. Now this is a very rudimentary form, I guess. Rudimentary proof. Let's go to the second proof, I guess. The second proof says if E is a subset of F, that means P of E will be less than equal to P of F. Okay. This is very obvious. Like the size of E is less than F, so logically you can understand under the same sample space, right? So it will be less than equal to 0. How can we do it easily anyway? So let's say there is some F is equal to some E union some A. Consider. So P of F is equal to P of E union A, or something like P of F is equal to some P of E plus P of A. So you can clearly see P of A can't be 0 here, right? So basically here then P of E will always be less than equal to P of F. That's a very interesting result. Okay, now let's go to the third result. Okay, the third result is a very important one, that P of A union B is equal to P of A plus P of B minus P of A union B. This is a very important result. Okay, how do we get this? Okay, so can we write F as, okay, so E union F, can we write it as E union E dash F? How can we see this? Can you tell this or not? So let's just imagine this, right? So let this be like, wait, let this be E, let this be E, let this be F. Okay, so first is E, so union mein E will be there. Okay, do we have a bucket tool though? Like, do we have a bucket tool? I don't think we have a bucket tool. Okay, so this will be E. Okay, then E dash F. E dash is this part, this whole part, this part. Okay, into F. That means only this part only is there. So union will be whole E union F only. So logically it's correct only. It's not wrong. Okay, it's wrong. So let's go further in the proof. Okay, so what I can do this. I can do probability of both sides. Why not? Okay, I can do it. Now I can write this as P of E plus P of E dash F, right? So this is a very good way of proving. So now can we write P of this, right? So now can we say this? Let's say can we say F is equal to EF union E dash F? How can we say this? Let's show you again. Okay, so how did we get this relation? Okay, yes, so F. Okay, so first is EF is this area, right? And E dash F is this area, right? So if we do in union of these places, so you get the whole of F, right? This is correct. So we can say this. So now what we'll do is that we will do a probability on both sides. So what will it be? Probability of F is equal to probability of EF plus the probability of E dash F, right? Now what we'll do, probability of E dash F is nothing but probability of F minus probability of EF. You substitute this here, okay. So now this becomes P of E plus P of F minus P of EF. We proved the formula. Okay, this is a very simple proof. You can also do it by drawing Venn diagrams and everything, but this is a bit more fun way to solve it actually. Okay, so like I am not going to show the proof by induction, but this is not true for 2, it can be for any big number. Okay, so basically let's say P of some A1 union A2 union and so on union AN. Okay, if this is the case, what will happen is that first you will do a sum of all PAI, means 1 1 1 1. Okay, then you will do minus of all the sum of P of A I, P of A I plus 1. Okay, not I plus 1, Pj, basically all the combination of that. Then we will do sum of, now by 3, with 3, then minus sum of 4. It will go on like pehle 1 by 1 1 1 1, then 2 2 2 2, then 3 3 3. It will go on infinitely. So this proof will be done by induction. This can be used as a homework for you. You can try it by using induction. So try to do it by induction. Okay. So that is the thing. Now let's talk about another different formula. That is a very important formula, number 5, I guess. Number 5 says PAB less than equal to P of A less than equal to P of A plus B. Plus is union, into is intersection. Okay, less than equal to P of A plus P of B. Okay, how do we prove this? So can we say like we showed earlier with F, right? So we can also write A is equal to AB plus A dash B, sorry, AB dash, right? So we take the probability both side, divided, like using the axiom 3, we can write AB plus P of A B dash equal to P of A. Simple logic. Okay, so now we can easily say that P of AB has to be less than A, otherwise this equation does not stand true, right? So P of AB has to be less, P of AB plus something is P of A. So this part has been proved. Okay, now let's try to see this. Now we know the earlier formula, what? P of A plus B is equal to P of A plus P of B minus P of AB, right? Now we can write this part as something like equal to summation of P of A plus P of A dash B. How did I get this? How did I get this? How did I get this? This is simply nothing but what? B is equal to P of AB. Sorry, B is nothing but AB plus A dash B. Similar to this equation. Similar to this equation. We are getting it similar from this equation. Okay. So nothing very different. So now you can see that what? P of A has to be less than P of A plus B. Simple logic. Then this is also proved. This part is also proved. Now last part, simple logic. Okay, P of A plus B, from this we will take this part here, so it will become what? P of A plus B plus P of AB is equal to P of A plus P of B. That means what? That means what? P of A plus B will be less than P of A plus B. So this is also satisfied here. So you have successfully proved this equation. Okay, this is the fifth equation that we have proved. Okay, let's solve the first sum. It says a committee of 5 is to be selected from a group of 6 men and 9 women. If the selection is made randomly, what is the probability that it consists of 2 men, 2 women and 3 women? So what is our denominator? Denominator is from 6 men and 9 women is 15. So 15, I have to choose 5 people. So this is our denominator. What is our numerator now? So 3 men. So out of 6 men, I have to choose 3 into out of 9 women, I have to choose 2. So this is the answer. It is as simple as this. This was just a one-line answer and nothing else. Okay. So the final problem of the day. So let's say there are n people in a room. What is the probability that no two of them celebrate their birthday on the same day of the year? How large will n be so that this probability is less than this? So the denominator will always be 365 to the power n, because anybody can have any birthday twice also, thrice also. It's up to them, right? So like we can't say. So above, what will it be? So first it will be 365, means none of them are there. Okay. Then we have to multiply it with 364 because we have one less common, right? Then 363, and how long will it go till we get 365 minus n minus 1. Okay, so these many cases, this is basically the probability, nothing else, I guess. You are multiplying these, by the way. Okay, so what will be, how large n needs to be such that this probability is less than 1 by 2. So how this to solve this sum? Just equate this to 1 by 2 and solve for n. Okay, so upper one is a simple GP and you can solve it using GP, and Yeah, it's that easy as sum. The answer is 23. It's a fun fact, you should know. Like if you have 23 people in a room, there is a 50-50 chance that 50% chance that both of them will have a common birthday. Okay, so this is a very fun thing. So at the end of this, I'll attach a problem sheet. Please try to do the problem sheet, and I think everybody has understood this today. So let's move on to the next video the next day. Bye bye.